Okay, today we're going to be talking about prime factorization. So first thing we have to understand is what a factor is. So what is a factor? A factor are whole numbers that are multiplied to find a product. So factors, again, are the numbers that you multiply to get a product. What are the factors of 14? So we need to figure out what numbers are going to go into 14. So we're going to list them from least to greatest. So we know that 1 can go into any number. So 1 times what number is 14? We know that 1 times 14 is 14, so 1 and 14 are factors. And then we know that 2 can go into 14 because 14 is even, so 2 times 7 is 14. So 1, 2, 7, and 14 are factors of 14. What is a composite number? A composite number is a number that has more than 2 factors. So that means that the number has factors other than 1 in itself. What are the factors of 24? Okay. Well, 1 can go into 24. 1 times 24 can go into 24. So 1 times 24 is 24. So 1 and 24 are factors. 2 can go into 24 because using our divisibility rules, 24 is even. So 2 can go into any even number. So 2 times 12 is 24. So 2 and 12 are factors of 24. 3 can go in. Again, you can check the divisibility for 3. So if you add the digits 2 plus 4, you're going to get a sum of 6. That sum of 6 is divisible by 3, so that means 3 can go in. So 3 times 8 is 24. And then we have 4 times 6 is 24. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. What is a prime number? So a prime number is a number that has exactly 2 factors, 1 and itself. Okay? So examples of prime numbers would be 2, 3, 5 to begin with. Okay? So 2 only has 1 and 2. 3 only has factors of 1 and 3. 5 only has factors of 1 and 5. So what are the factors of 53? Well, 53 is going to be a prime number, okay? So the only factors that go into 53 is 1 and 53. And again, if you are not sure if this number is prime and you think it's composite, then use your divisibility rules to figure that out. So, for instance, 53, okay, it's not even, so 2 can't go in it. Does 3 go in? Check the sum. 5 plus 3 is 8, but 8 is not divisible by 3. See if it's divisible by 4. No, the last 2 digits of the number have to be divisible by 4, so 4 can't work. Does 5 work? No, it doesn't end in a 5 or a 0. 9 doesn't work because the sum of the digits have to be divisible by 9, and 10 doesn't work because it doesn't end in a 0. And in order for 6 to work, both 2 and 3 have to go in. So 53 is a prime number, 1 times 53. So that lends itself into our topic of prime factorization. Prime factorization is a number written as a product of its prime factors. Okay, so in other words, prime factorization is like a multiplication sentence of all the prime factors that go into a number. So all the numbers that are multiplied together have to be prime for prime factorization. So what I'm going to show you in this lesson is the ladder method with prime factorization. Now in class, we might go and review the tree method to figure out prime factorization. But in this video, I'm going to go over the ladder method. So if I wanted to find the prime factorization of 24, what am I going to do is I'm going to draw an upside down division symbol, and I'm going to put the number inside. And then what I'm going to do is on the outside of this ladder, I'm going to think of a prime number that can go into 24. what comes to my mind is 2. Well, because 2 can go in an even number and 24 is even. So I'm going to try 2. And then I'm simply going to divide 24 divided by 2, or how many times does 2 go into 24? Well, 2 into 24 goes 12 times. And I'm going to get to the, how I know I'm done is that I'm going to end up in the end with a prime number, okay, at the end of this. But 12 is not prime, so I got to keep going. 12 is composite because it has other factors besides 1 and 12. So I'm going to do this again. And I'm going to think about a number that can go, that is a prime number that can go into 12. I can use 2 again. 2 into 12 goes 6 times. Okay, so then I check. Well, 6 prime? No, it's not, because 1 can go, 6 can go, 2 and 3 can go. So I got to keep going. So I can use 2 again because 2 goes into 6. 2 into 6 goes 3 times. Okay, so then 3. Okay, 3 I know is a prime number, so I am done. There's nothing else I can divide into it except for 1 in itself. So what ends up happening on the outside of this ladder, okay, is all prime numbers. That's the goal. I have to end up with all prime numbers. So what I'm going to do is I'm going to circle them. 2 is prime, 2 is prime, 2 is prime, and 3 is prime. Okay, so I'm going to write out the prime factorization, and prime factorization is going to be the product, means multiplying, of all the prime factors. So that means I'm just going to rewrite it as a multiplication sentence. So all I'm going to do is I'm going to write 2 times 2 times 2 times 3. What I'm just writing is the prime factorization. All the numbers that are prime multiply together to equal 24. So if I multiply 2 times 2 times 2 times 3, I get 24. This is prime factorization. It's going to be the string of prime factors that make up 24. Now I can also simplify this further and write this as exponents. Well, I have 2 and it repeats 3 times. So 2 to the third times 3, which is the same thing as 2 times 2 times 2 times 3, except I just used exponents. Okay? So let's try 144 using this method. Again, I'm going to draw my upside down ladder, my upside down division symbol. I'm going to think of a number that goes into 144. Okay? Well, 144 is even, so I can start with 2. Well, how many times can 2 go into 144? So if I'm not sure, I can do kind of on the side here. I kind of have to do on the side here, see how many times it can go, and that's okay. 2 into 14 is 7, right? 2 into 4 is 2. So it goes in 72 times. Okay? So 2 into 144 is going to be 72. Well, 72 is not prime, so I got to keep on going. Can I use 2 again? Absolutely. It is even. How many times does 2 go into 72? Well, again, if you're not sure, do the math. Do the math on the side if you're not sure. Do it the long way. It's okay. 2 into 72 is going to be 36. 36 is not prime. I got to keep going. Can I use 2 again? Yes, I can use 2 again. 2 into 36 goes 18. I got to keep going because 18 is composite. Can I use 2 again? Yes, I can use 2 again. 2 into 18. Well, 2 into 18 is going to be 9. Okay? Well, 9 is composite because 1 and 9 and 3 goes in. So it's definitely composite. Now, I can't use 2 again, but I know that 3 is prime and it can go into 9. So 3 into 9 is 3. And I'm going to end up with a prime number. So again, I'm going to circle all my prime numbers on the outside of the ladder. And then I'm going to rewrite them as a multiplication sentence. So I've got 2 times 2 times 2 times 2, okay, times, I'm going to write this, times 3. So this one goes with that one, with that problem, okay? Or I can write it as exponential notation. So I can write 2 to the 4th times 3 to the 2nd. But I can write this in any order. I can do 3 to the second times 2 to the fourth, or I can do 2 to the fourth times 2 to the 3. You understand that you can write these numbers in any order in multiplication. Okay? All right, so let's go ahead and do 66. So again, prime factorization of 66. Put 66 in there. What prime number goes into 66? Well, I can try 2. 2 into 66. I know that's 33. 33 is not prime, so I got to keep going. Well, 2 can't go in 33, but I know 3 can. Okay, so 3 into 33 gives me 11. So 11 is prime, so I got to stop there. Nothing else can go in. I'm going to circle all of my numbers that are prime. Then I'm going to write the sentence 2 times 3 times 11. Again, if you multiply 2 times 3 times 11, you're going to get back where you started with, which is 66. And I can't do this in exponential notation because nothing repeats. Let's do 36. So again, what prime number goes into 36 on the outside? I can start with 2. I can also start with 3. That's fine. Doesn't matter, as long as it's a prime number. 2 into 36 goes 18 times. I got to do it again. 2 into 18 goes in 9. Again, it's 3. It's going to be 3 this time. 3 into 9. 3, I end up with all prime numbers. Circle your prime numbers, and then write it out. 2 times 2 times 3 times 3, or 3 times 3 times 2 times 2. And I can write it out in exponentially, 2 to the second times 3 to the second, or 3 squared. So 2 to the second times 3 squared is going to give me 36. That's how I know I did it correctly. So again, this was the ladder method with prime factorization. And so make sure you are copying these notes down in preparation for our practice with prime factorization on the next day that we're doing this.